Let's create this belt and pulley analysis in Creo Parametric. And as you can see, we are going to see how we can create this analysis in Creo. Okay, therefore, let me close everything here. I'm going to just close this here. No, don't save anything. I'm going to delete all this. Yeah, and let me open this and show you the dimensions. Let me take you through what I have done. I'll just go back. I have this sketch onto the front plane. I said any plane doesn't matter, whatever the plane, 25 by 120, and I'm using millimeters. Then extrude that sketch by, you can see dimensions here, by 25. That's the adduced symmetry. You can see this line indicates this is a symmetry. Oops, then go back here. I have this sketch of 85, then extrude cut a depth of, let's see the depth of 10, then mirror it to the other side, then another sketch here. Let's see this sketch here. Ensure this circle is 12 by 25 from the midpoint. Then pattern this one to have 5 of them. Then let's see this sketch. Let's see this extrude 4. Then dimension here, and so we have now this one 27 by 25. This one doesn't matter, you can use any dimension here, just to define a small section wherever you want. Yeah, then let's see the sketch. This is the sketch that will define the pulley. Remember, this is the sketch for the pulley. I'm using 6 by 3, and I should have 3 here. From this point to this point, I should also have 3. Yeah, I should have 3 also. And yeah, make sure that, yeah, this one is 60 also, this is 60. Make sure that it is fully defined or sketch. Yeah, then revolve and cut. And this one is our first pulley by the name pulley 1. Let's go to pulley 2. Pulley 2 is the same design but smaller. Just make it smaller. You can maybe reduce all those values by maybe a factor of 2, whatever the value you need. It is the same thing, but this sketch has to be the same. We must use the same sketch here. 60. Let me just fully define this. For some reason it's not fully defined. 3, this to this to be, must be 60. Yeah, that is what we have. Then if you go to assembly, let me just ensure that let me just go back a little bit and explain what I have done. Show the planes. I have this axis. Create an axis that is between the intersection of this plane and this plane, these two planes, that is right and top. Create this axis here. You can see intersection of right and top. Therefore, right and top plane intersection. You should have a plane, just an axis, right and top plane intersection. Then I have another datum plane that is 200 from the right plane. You can say here 200 mm, This one is called datum. I could just give it a datum plane. That's 200 there. Then intersection of this datum plane and your top, you have another axis here. That is intersection. Let's go to properties. This one is called top versus datum intersection, like that. Okay, you have those planes now. Insert your pulley one. This is my pulley one. Let me just delete. Let me delete this. Delete, and yeah, delete. Basically, just insert your pulley one. Let me just delete them. Let me first for copy paste. Let me just use for now. Let me use the default. Okay. Let me delete this connection here. How to delete it? Remove, delete. Yeah. Once you insert the first pulley, ensure that you can first of all deactivate the planes, and let me first of all delete this. Okay. Okay. Let me see if I copy this. Copy and paste. Yeah. From now, let me use default for now because I want to delete the first one. I think that's better. Again, copy this and paste. I want to use default. Why is it having this? Let me first of all go here, then disable this thing, disable it like that, so that I can now copy and paste using default, using okay, wherever. Don't know why it is okay. Let's do this assembly from scratch. Basically, once you have your datum, your axis, both axes, now insert your pulleys one by one. Therefore, go to assemble and insert pulley one. This is my pulley one. Then for now, just use default. For now, use default. Again, assemble, insert pulley two, and you call it default. Yeah, give them default for now for a start. Okay, then we need now to, you see this small axis here is where we're going to assemble it. This axis, this top datum intersection, this one, I'm going to assemble it with the pulley 2. Therefore, let's first for hide pulley 1. I want to move this to this axis to ensure it can rotate and activate the planes. Okay, therefore, right click this one, edit definition. Instead of using default, just delete and use what we call pin. And for the pin, I want this and this. Therefore, this and this. Oops. For the assembly, select this. Oh, sorry, here. For the assembly, select this. And for the component, this one here. Then for the translation, select this plane and this plane. Then say OK. Okay, you can now try to test to move your part. You see it is able to rotate, but it cannot move, it cannot translate. Then show your pulley 1, show it again. For the pulley 1, right click here, just select, delete this default and use pin. Again, for the axis, component axis, select this axis, assembly, the axis we created here, that is right. That's the axis. For the translation component, this plane, assembly, this plane, then say OK. then try to test whether it will rotate. See, it is rotating. Then hide everything else. For the belt to work, these ones they have to rotate. Therefore, just check whether they are rotating. Next is we need now to insert Pulley between these two surfaces. You go to the mechanism, application mechanism, then select belts. For the belts, you just need to define two surfaces where the belt will rest on. Can see this surface and this surface. Then say OK, just like that. Then if you scroll down to the belts, look for the belt here, connections, belt. This one, right click this one and make part. Convert this to part. Just right click on the connections, belts, right click, make part. And you can now give it the name of belt, belt part, like that. You can use an empty for now. If you now close here and go, you can see now we have this curve that presents my belt. Right click here, right click this belt part, make it active. I want now to sweep onto this surface to create the body of the belt. Swipe, select this one here, shift and this, shift, ensure you select shift, then go to sketch, orient normal, then take references of these ones here, then create a profile for the belt like that. You can have some offset if you want, like that. Then just go to the standard orientation, then activate your assembly. If you want to assign some appearance to this belt, just go to view, maybe this to the belt, then say okay. Then once you go back to the model and start to move this, you can see it is moving. If you want to animate this, you can go back to application, mechanism, and select servo motor. For the driven entity, select this profile. Let's use what we call velocity. It's constant. You can use ramp, you can use polynomial, parabolic. Let's just use 40 and say okay. Go to make analysis here. Let's first for delete this analysis and create a new analysis. Go to analysis here. I want us to use kinematic 1010. Let's leave everything as default for now. You can see, then say okay. You can go to playback and you can play your analysis here, play, and you can increase speed. You can see how the belt is animating. That is how we create animation of belt in Creo Parametric. Thank you and stay tuned for more.